Hello everybody and welcome. So in continuation on what we started on types of forces, today we will be talking about normal force. Okay, so what is the normal force? Actually, it's something, well, that's taking us back to Newton's third law. We're just going to demonstrate Newton's third law and call it normal force. In other words, according to Newton's third law, every action has a reaction. Now, this reaction force is whenever an object pushes a surface back, and we call it a normal force. So it's, in other words, it's just simply the pushing back force that we introduced in Newton's third law. We will be calling it the normal force. Now, there's no specific formula for the normal force, but we can say that the normal force depends on the situation of the surface the object is standing on. In other words, we will have two types or two main scenarios when we are dealing with the normal force. The first scenario is when we have a horizontal surface. When we have a horizontal surface, we can simply say that the normal force or the pushing back force when the object is on a horizontal surface, it is simply equal to the weight, because we learned before that every action has a reaction. So we know that the action here is the weight, and the reaction here we will call it the normal force. Now, the other case we will be dealing with is when the surface is not horizontal, or we can call it an inclined surface. Now, the other case is when we have something called an inclined surface. In other words, the surface is not horizontal anymore. In this case, we can say that the normal force, it's equal to the weight multiplied by cosine theta, and theta here is then the inclination angle. So let's look at this picture right here. If the surface, as you see, it's not horizontal anymore, we call it an inclined surface. We have an inclination angle, we will call it theta. We can say that simply the normal force, it's equal to the weight multiplied by cosine of this angle. Okay, so two cases. One of them is when the force is horizontal, or when the surface is horizontal, we can say that the normal is equal to the weight. And the other one is when the surface is inclined, we can say that the normal is equal to the weight multiplied by cosine theta. Okay, so let's try this right now really quickly. We can say that the first example says a 10 kilogram box is resting on a horizontal surface. Find the weight and the normal force of the surface exerting on the box. So simple, if we want to draw it, we can say that this is the box. We have it on a horizontal surface. It has a mass that it's equal to 10 kilograms. Okay, some of you may be a little bit hasty and you can say, oh yeah, so the normal is also equal to 10. No, you must be careful and concentrate. Here we have the weight, and we already introduced the equation to calculate the weight, which is m multiplied by g. So we can say that it's equal to 10 multiplied by 9.8, so it's equal to 98, and the unit is newtons because it's a force now. And since the horizontal or the surface is horizontal, we can say that the normal in this case is simply equal to the weight. Now, if the surface was inclined by 30 degrees above the horizontal, find the weight and the normal force. Well, nothing really changed. This is the surface. Now it's inclined by 30 degrees. We can say here that this is 30 degrees, okay? And this is our object. Now we know that the weight, we already calculated the weight. The weight is equal to 98 newtons. Okay, now since the surface is horizontal, it's not horizontal, it's inclined. The weight is pointing this way, but the normal is pointing perpendicular to the surface, because we learned that the action or the force, the surface is pushing back perpendicularly, so we can say that this is the normal force. So simply the normal is equal to 98 cosine of the inclination angle, which is 30. Okay, I hope now things are more clear about normal force. Now let's introduce another type of force, which is called the tension force. Actually, the tension force is very easy and very clear. Simply, we can say that the tension force, it's simply the pulling force inside a rope or a cable or a chain, and it's exerted along the whole length of the cable. So the tension force inside a rope is equal to the force applied on that rope. So there's no specific formula to calculate the tension force, but you just need to know that if there's a force inside the cable, this force is called a tension force. So let's look at this example. In this image on the right, a cat has a mass of 5 kilograms and it's hanging from a rope. Find the tension inside the rope. Look at this image right here. It's very straightforward and easy. Since the weight or the cat has a mass of 5 kilograms, now mass is not a force, we can say that the weight is 5 multiplied by 9.8. So in this case, we can say that the weight here, it's equal to the tension force. The tension force is equal to the weight. Again, concentrate that this is the mass of the cat, not the weight of the cat. So we have to transform it into weight by multiplying it by 9.8. Okay? Now, another example, a man is pulling a rope that is tied to a wall with a force of 50 newtons. What is the force inside the rope? So let's imagine that this is a wall here, and this is the rope, and he is pulling the rope with a force that is equal to 50 newtons. I can straightforward say that the tension is equal to the force that is applied, and it's equal to 50 newtons. Actually, this is also very related to Newton's third law, because every action, which is the 50 Newton force, has a reaction, which is the tension inside the cable, that's equal in magnitude but opposite in direction. So we introduced two new types of forces, which are normal forces and tension forces. Now we will be using these forces from now on to deal with dynamics problems. So the most important part of this chapter is yet to come, which is how to deal with dynamics problems. Stay tuned. See you in the next video.